Cancer is not a modern disease. It's one of the oldest problems humanity has ever faced. Records from ancient Egypt and Greece speak of a sickness that seemed to defy explanation. A mass that grew without cause and resisted all attempts to remove it. What changed over the centuries wasn't the disease itself, but how we understood it, how we saw it, and ultimately, how we learned to fight it. This is the story of that understanding, a long, slow journey from mystery to science. Thousands of years ago, cancer was already described. The name itself, karkinos, comes from the Greek word for crab, an image meant to capture how the disease grips onto tissues with claw-like veins. It was seen as something that grows, invades, disappears, and then returns. The earliest doctors, limited by the tools and knowledge of their time, believed cancer was simply unstoppable. And for many, many centuries, they were right. It was a force of nature, an internal curse, something to be endured but never conquered. For over 2,000 years, the dominant idea was that disease came from an imbalance of fluids in the body. The four humors. Cancer was thought to be caused by an excess of black bile, a melancholic dark fluid. There was no concept of a specific tumor, no idea of a cellular origin. The entire body was sick, and the treatments, like bloodletting or dietary changes, were designed to restore a lost balance. Everything changed when scientists looked closer, much closer. With the invention of the microscope, a new world opened up. They discovered that the body wasn't made of humors, but of tiny living units, cells. And in the 19th century, a monumental realization dawned. Disease begins in cells. Cancer was no longer a mysterious fluid imbalance. It became a cellular disease. That single shift transformed research forever. It gave science a target. If cancer starts locally, in a specific group of cells, then maybe removing that group could cure it. This was the birth of the surgery era. Surgeons reasoned that if a tumor was removed, along with a wide margin of healthy tissue around it, the disease could be completely eliminated. The logic was sound. Radical mastectomy, for example, became a standard procedure, removing not just the tumor, but breast tissue, lymph nodes, and even chest muscles. The results, however, were often devastating. The procedures were disfiguring, and despite their brutality, the cancer frequently returned. It was a hard lesson. Science can be rigorous, logical, and still profoundly wrong. The problem wasn't just local. Modern cancer drugs didn't come from hospitals or quiet university labs. They came from war. During World War I, soldiers exposed to mustard gas suffered from severely depleted white blood cell counts. After the war, scientists wondered, if this chemical destroys healthy blood cells, could a similar compound destroy cancerous blood cells, like those in leukemia? The 1940s, they tested a related chemical, nitrogen mustard, on a patient with advanced lymphoma. The tumors shrank. It was a breathtaking moment. For the very first time, a systemic cancer responded to a drug. The age of chemotherapy had begun, but it was a fragile victory. The cancer always came back, resistant to the very drug that had once beaten it into remission. One drug was never enough. Cancer, it turned out, was a master of adaptation. A single tumor isn't a monolith of identical cells. It's a diverse population. A drug might kill 99% of them, but the 1% that survives is by definition resistant. Those survivors then multiply, creating a new tumor that the original drug can no longer touch. So researchers tried a new approach, borrowing an idea from the treatment of tuberculosis. The idea of combination therapy was born. Not a single weapon, but a coordinated multi-pronged attack, hitting the cancer with several different drugs at once. Each with a different mechanism of action made it much harder for resistance to develop. It was a game of chess against an evolving opponent, and for the first time, science had a strategy that led to lasting cures for some cancers. But cancer research doesn't exist in a vacuum. The 1970s saw a war on cancer declared in the United States, pouring unprecedented funding into the field. This brought huge public attention and resources, but it also created immense pressure. Money, public fear, and political promises began to shape research priorities. The public wanted a single magic bullet cure, and they wanted it soon. But biology doesn't obey press conferences or political deadlines. It obeys its own rules of complexity. The massive funding did accelerate discovery, but it also revealed just how incredibly complicated the problem was. There wasn't one cancer, but hundreds of different diseases, each with its own biology. The promised cure remained elusive. The next, and perhaps biggest, shift came when scientists finally deciphered the language of life itself: DNA. With the genetic revolution, our entire view of cancer was turned on its head. Cancer stopped being seen as a foreign invader, like a bacteria or a virus. It was revealed to be something far more intimate and unsettling. Cancer isn't an outside attacker. It's our own biology, our own cells, pushed to extremes by mutations in our DNA. It's a disease of our own genes. Cancer is a process of evolution happening inside our bodies. It's driven by mutation and natural selection, where the fittest cells are the ones that grow fastest and ignore the body's rules. It's not one disease. It's 1,000 different evolutionary paths. This new understanding also highlighted another critical truth. Sometimes, the most powerful way to fight cancer isn't with a new drug, but by preventing it from ever starting. The field of epidemiology, the study of disease in populations, drew undeniable links between certain behaviors and cancer. The connection between smoking and lung cancer was the most dramatic example. Scientists proved that prevention could save more lives than treatment ever could. Public health campaigns, smoking bans, and education had a massive impact, reminding us that cancer is not just a biological problem, but a societal one. The fight against cancer wasn't just happening in the lab. It was happening in our laws, our schools, and our daily choices. Today, oncology is in an era of precision. We've moved from the blunt instruments of radical surgery and carpet-bombing chemotherapy to treatments that are targeted and personalized, instead of poisoning all fast-growing cells. New drugs are designed like molecular keys to fit specific locks, the very proteins made by mutated cancer genes. Immunotherapy is teaching our own immune systems to recognize and attack cancer cells. We are learning to read a tumor's specific genetic code and tailor a strategy just for it. There is no single cure on the horizon because there is no single cancer. But there are many, many partial victories, turning what were once fatal diagnoses into chronic, manageable conditions. In the end, cancer is a disease of survival. It exists because cells are doing what they have evolved to do for billions of years: grow and divide. Cancer is just that process, untethered from its natural controls. The long, winding path of research has led us to a profound truth. The goal may not be a final conquest, but a state of control. Understanding cancer, piece by agonizing piece, didn't make it disappear. But it took away its mystery, and in doing so, it gave us power over it. Thank you for watching.